Hi, and welcome to this module in our Tetration video series. I'm joined by Rob, and we're going to be talking about the types of data that you can bring into Tetration. So Rob, there's a couple of different data sources that we support in Tetration. It's not just simple flow data, right?
Okay. I know there's agents which we can deploy to the workloads, and they're going to bring us telemetry in. What else do we actually need to bring into the system to complete the picture, Tim?
Yeah, so agents bring us flow data, flow data being one of the major components, but there's so many other bits of useful information that Tetration can help you gather to build the complete picture of what exactly is going on in your network.
Okay.
We talk about it in our early session on the life cycle of policy and also on the reason to deploy Tetration, and one of those things is that you can't secure anything until you have visibility. You need to know exactly what is going on in your environment.
Right.
And visibility is not just related to flow data. That's just a mere portion of the entire story.
Okay, excellent. So we've got different ways we can get data into the system. Flow data is part of that.
Yeah.
What other things do we actually need in there to build out the kind of picture we need for Tetration capability?
Well, let's walk through together and take a look at the different sources of data that we can bring into Tetration that aren't just limited to flow information. So obviously we do grab you flow telemetry. This is one of the major pieces of the Tetration telemetry data sources. This flow telemetry being very, very detailed. We'll actually step through the level of detail that flow telemetry goes into. But the key point to remember is that it is a view into every single flow on your network. We're not talking about sampled flow data here. We're not talking about taking spans or taps at particular choke points. Okay. The goal is to get that complete visibility across all flows, north to south and east to west.
So saying it's a little bit different to say how we would get net flow out of the switches in the environment.
Exactly. We want to be getting this flow data from the closest point to the application or the user.
Okay.
Whether that comes from something like AnyConnect in the campus or a software agent installed on a workload in the data center, it's imperative to be as close as possible to the source of truth. And the source of truth, in most scenarios, is the application itself.
Okay, and that then starts to get us outside of the issues and the challenges a lot of customers have in terms of how do we get visibility not only in the physical network, but we've got virtual environments, we've got containers, we've got all these different ways that we deploy our workloads today. There's very little that's actually consistent across all of those to actually get the telemetry data from.
Yeah, it really does away with that headache of having to chase around the infrastructure to find different points in the infrastructure where you may or may not, most likely may not, as applications change, be able to get that visibility. And furthermore, because we are not relying on infrastructure devices to provide us that flow data, we're not dealing with some of the scaling issues that you most often run into there. We've all had that scenario where we've had to, back off the net flow on a particular router or a switch because it's potentially impacting that switch in some way or another.
Okay, so we've got a very scalable telemetry collection system here to actually get certainly flow data coming in. But since we've got effectively agents that are deployed in the workloads themselves, what else do we actually get out of those?
So alongside the flow data, we start to bring in some more interesting information. We start to pair that flow data with the process. So the process gives us that capability to say, not only was this traffic on the wire port 80 or port 443 or whatever port that traffic is, we can pin it down to the actual application that was generating or receiving that traffic.
Okay, so that's really good to know. And I guess particularly if I'm, say, doing application dependency mapping, it's one thing to know that I've got certain TCP services being presented for application use, but to actually understand what's the process that underpins that, it really helps to build out that picture, right?
Yeah, so imagine you're doing some sort of analysis on the flow data in your environment, and you want to search for all flows generated by a particular process, whether it's a Java process or a particular web server like Nginx or a load balancer like HAProxy. You can go through and find flows relating to those specific processes. So you're no longer bound by the need to correlate the exact port with the process through something like DPI. You don't have to analyze the payload of the traffic. You don't have to try and work out what the process is. We can actually empirically say this traffic was going to this socket on this workload, which was listening with this process.
Okay, that's good to know, particularly since the vast majority of traffic and increasingly is being encrypted, right?
Yes.
So it's kind of going a bit dark for us, actually understanding what's on the endpoints and what are they doing, how are these flows actually being initiated, and who's serving those capabilities is really important.
Yep.
Okay.
And especially like you mentioned, as encryption becomes even more prevalent across the industry, we talk about newer encryption standards like TLS 1.3. In many ways, it's going to become impossible to actually look inside those payloads. So the only logical place to start capturing this data becomes via a software agent on that workload itself.
Got it. Okay. And I see here that not only have we got it, say, in terms of a server workload, but this looks to be like a client machine here as well, Tim. How does that play out?
Yeah, well, applications don't exist in a vacuum. There's always going to be some user, some pesky user that actually wants to access that application. It would be nice if we could build a walled garden and never let them access it, but we do have to open up those applications.
Yep.
And so therefore, it's very nice to be able to not only get visibility into the flows coming from those users, but to get more information about exactly what they were doing on that user side so that we can build more secure policy in the data center, or potentially if we need to do some sort of forensic event or go back and look at flows relating to a particular user or some identity of that user.
Got it. Okay, so we've pretty much got an end-to-end picture we can start to form. All of the workloads, understanding how they're communicating, the process behind those, and extending that out to the user base as well.
That's it.
It's not just a matter of trying to piece a picture together based on just pure flow communications.
Correct. But if you think about that picture, we have discussed flow data and we've discussed process data, but there's some other data that is useful to capture around those workloads, which is really who are they, what are they doing, what are they supposed to be doing. Okay. And that kind of metadata we could refer to context data. We capture that in the form of annotations, and that is the third piece of data that Tetration is really going to start bringing into the system.
Great. So we've got a couple of examples here, and you sort of mentioned coming in from external systems.
Yeah.
I guess there's even other elements of context we even get from the agents themselves as well, right?
Yes, that's correct.
Yeah.
So the agent itself gathers a base set of context around that workload. It's going to capture things like the packages that are installed on that workload, the processes that are running, obviously the operating system and the version, all of the interfaces on that workload and the hostname of that workload. So just by getting that agent deployed on that application workload, you get a huge wealth of information to come into the system.
Right.
But then, like you can see on the screen here, we can integrate Tetration with what we call external orchestrators, and there are other modules in this series that discuss external orchestrators in depth. But what that allows us to do is ingest context and metadata from those external systems about the workloads that might be running on them.
Okay. All right. Now, I see we've got a few examples here, and again, it seems to sort of cover that range from what we would know about our workloads. So we've got things like IPAMs in here. We've got cloud providers. We've got hypervisors. So they're going to give us context and maybe a understanding about how those workloads were deployed, whether there were any tags associated to them. So really, what was the intent of the application owner when those were actually being deployed? Yeah,
each one of these systems becomes a system of record often. And as we've seen in the demo on the slide here, we can see, for example, that AWS is going to know a lot about an EC2 instance. It will know the resource ID. It's going to know the name of that. If there are any tags applied in AWS, they certainly will be useful to have those tags also visible inside Tetration.
Got it.
Similarly, on the user side, who is that user? Who's logged into that device? What department might they be part of? All of that context and metadata becomes very powerful when you're trying to do analysis of flows, dependency mapping, and finally to enforce policy. All of that information is incredibly useful to you.
Excellent. Okay, so we've got things from agent, things from external systems, and I guess Tetration does the job of combining those all together, right? And we've got this inventory that understands everything that's communicating, and we're able to pull the appropriate bits of information here to populate that and give us the most richest context we can get for each IP in the environment.
Yeah, bring all of your data to Tetration. We are a
Yep.
big data system. We do have a big data underpinning our product. So we do want all of this information. Keep sending it in. If you have information in Kubernetes, if you have information in AWS or Infoblox or vCenter or ICE, send it over to us and
When you
we'll be
say
able to use it.
All is a big word, Tim. You really want all of the data?
We want data that makes sense
Yep.
to you when you're going to start doing something with that data. Don't
Okay.
needlessly bring context in.
So no junk.
No junk.
Just the valuable information in the context that is relevant in.
But bring it from the systems that are relevant, and don't be afraid to bring something in that you might find useful.
Okay, excellent.
So we have the main Tetration data sources: flow telemetry, process data, and context data. Let's take a little bit more of a look into exactly what they provide us to build up the full picture.
Okay.
So, flow data. We can collect flow data primarily from the software agent. That is the way that we would recommend that you get visibility in the data center. That software agent, which we have other modules on, and we'll go into a lot more depth exactly how that software agent works, what it supports, how you can configure and deploy that software agent. But for this session, we can understand that that is going to be deployed across the majority of workloads in a customer's environment.
Can we get flow data from other sources though, Tim? Let's just say there was something we couldn't get an agent deployed to, as an example.
Yes, while we recommend the agent goes on as many workloads as possible, if you do have workloads that can't have the software agent installed on them, we do have alternative ways of capturing pure flow data. We would recommend that you use the Tetration ER-span option, which allows you to take flow data from network devices, convert it into Tetration telemetry, and ingest that into the Tetration platform. So we can capture data from network devices or workloads that we can't get that software agent on in a scalable and accurate way.
Okay.
You can also see on the left-hand side here that we can collect data from systems like AnyConnect. We can get data from ASAs. There is the capability to bring in data about the workloads out there in the campus. So flow data we have checked with Tetration.
Okay.
And that brings one piece of the puzzle. But we can look at the flow data in very, very detailed accuracy.
Okay.
This is not just your typical NetFlow level of visibility. We're not just giving you the 5 tuple, this is who spoke to whom, but we're actually looking inside that flow. We're looking at the per packet variations so that we can make more informed judgments about exactly, is that flow good, is it bad, should we use that for policy?
Okay, so what would be an example of how and where it'd be useful in this case? Like, so the TCP flags, what value does that add, Tim?
Apart from the fact that it's cool to know what the TCP flags are, here's a good example. So imagine that we have some device in our network that is doing a port scan across our entire data center. And that port scan is sending out lots of SYN packets. Now, would you want to build a policy based on those flows that don't complete the handshake?
So basically, I'm being scanned, I'm just resetting or effectively rejecting those. There's no session being established here.
Yes.
So it doesn't sound very worthy of actually creating policy around that.
It really doesn't sound worthy of creating policy of that. And that's why it's useful to have that information. Was this a real legitimate flow? Did both sides of the conversation actually accept to talk to each other? Should that flow be considered for a policy in our policy generation tool?
Okay, so just because data was exchanged doesn't make it a really useful, say, business generating flow that deserves a role in the policy.
Yep.
Okay.
And that's why we go down to that level of capturing the TCP flags. So we know about the flow, we know about the lifetime of the flow, we track that flow. Even if it's going on for multiple days, you will see the entire flow captured in one session inside Tetration.
Okay.
But inside that we'll have those very small variances that we can use to build a model about that flow.
That sounds also really useful for being able to maybe look at some sort of previous incident, maybe something that took place in the past, and be able to see what happened. Why were these sessions being reset, or whether it was maybe some malicious activity or otherwise? Yeah,
it is just useful from a pure visibility perspective to be able to say, show me flows that experience these kind of conditions. Lots of reset flags, lots of retransmissions. Those kind of things are very powerful from a visibility perspective.
Okay.
So we've got flow data down. Now we can start pairing that with the process itself. It's very powerful to be able to correlate the flow to the process. So here we're saying, for example, on port 443, it was nginx that was listening to the process.
Okay.
Or listening to that flow, I should say.
Right, so that way I couldn't necessarily just create my own process and just listen on 443. If you were expecting it to be nginx, you're able to validate that and make sure that it's a legitimate, not only, I guess, the process, but even potentially to the hash, right? So understand, is it the right process that's actually serving that traffic?
Correct. Someone getting access to a workload and then masquerading as a legitimate process is a serious concern for end users. So being able to point that down to the actual process, take a hash of that process and compare that hash against known malware feeds, that's really going to be able to give you that capability to say, is this good or is this bad? Should I bake this into my segmentation policy?
Okay.
So processes helps you get deeper into the workload, understand a lot more about that flow and why that particular flow is there.
Great. It seems like certainly going a level beyond, you get if you're just doing pure flow analysis, you're never going to actually get to the truth of what's happening there.
It also helps bridge that gap between the developer and the centralized IT team. Developers often aren't well experienced in networking constructs. They may not know what an IP address is or what port they are listening on, but they will know a lot more about the process or the executable that their application should be listening on or providing that service on. So it helps you correlate those two worlds which often never would see each other before. So we take the process data and we also take the hash of that process so that you can validate that it is a legitimate version of that process and it's not someone masquerading as something that it shouldn't be there.
Okay.
Seems useful, right?
All right. And how can we actually validate that? How do we know whether this hash is malware or not?
So Tetration has a connection to a threat intelligence feed. That threat intelligence feed will take those hashes and it will look it up against a known database of malware.
Okay.
So it's going to flag for you straight away, hey look, you have network traffic and that network traffic is going to processes which we really don't think should be running in your environment.
Right, that's definitely something worth knowing, right?
It's definitely something worth knowing, especially if you think about the fact that that scales across your entire estate. Not just one or two machines, but every machine in your environment, we're checking for these process hashes.
Got it, got it. So if there was, let's just say if this was a bad hash, can I see if I've got it anywhere else?
Yeah, you can search across your inventory, which we discussed in the inventory module, and you'll be able to say, show me all workloads that are running this process with this hash.
Okay.
Further, you can even go, and we talk about this in our policy module, how you can use that hash to block traffic to those workloads.
Great. So all of this context that we're actually building in is not only like per workload, but we've got the visibility across the entire inventory. We can search across any of those particular elements of context to see what is matching in there.
Any of the fields that we're looking at right now, we can actually search across the inventory for.
Great.
So we have the understanding of the process, and the final piece of the puzzle is bringing in the contextual data. Read that IPv6 address there, Rob, and tell me exactly what workload is running behind that address.
I'm not going to read that, Tim, and nor do I know who that belongs to. So.
No, I wouldn't expect you to, and I don't blame you. They aren't particularly easy to remember off the top of your head, right?
No.
So IPv4, maybe you might be able to remember a few important addresses, maybe your DNS server, your Active Directory servers, but for a given workload in your environment, can I correlate the address to an application in my head?
You know, I think I've got a spreadsheet somewhere that might have all the answers that you seek, Tim. It's about 100,069 lines long.
69, okay. And you keep that up to date?
It's refreshed rarely.
Rarely. That's a very polite way of putting it.
Yeah, no, it's one of those things, obviously, there's historically been many attempts to just try and track all this information. There's clearly systems that do it, you know, IPAMs and so on, to try and take some control of this environment. In a lot of cases, there are spreadsheets, right? But it is simply non-workable at scale and doesn't really help us with this problem.
Yeah, having the context data associated with the workload in a system that's also using that for policy discovery and enforcement means that you keep that context data fresh. And by bringing it in from systems like we discussed in the earlier slides where we could bring it in from AWS or from vCenter, it's going to be constantly kept up to date. Yeah. So rather than having to refer to IPs, we can start using the context data to deal with workloads. We can say, show me all workloads that have the tag as location equaling AWS, or show me all traffic from campus users that are part of the Active Directory group engineering.
Well, I think we've got a couple of extremes here, right? So in any data center environment, there's going to be workloads that are relatively static, and then there will be workloads that are delivered to cloud or even containers, right?
Yeah.
And so those IP addresses are constantly changing. Same in the user space. Also, users log out, log back in, reattach to the network, new IP addresses, but the context around those IP addresses is ultimately continually in a state of change.
Yes. And Tetration is designed to deal with that constant state of flux.
Yep.
We track these context data over time. We let you view it over a time series as well, so you can see how the identity of a workload changes. Yep. And that can be useful for policy enforcement down the line as well. So if we start putting the picture together, we can take the context data, the process data, and the flow data, and at that point we have a very clear picture, very detailed visibility about what is happening when there is communication between any two entities in your environment, whether that's inside the data center or from a workload outside the data center speaking to an application inside the data center.
And in terms of the tracking of this behavior, this is also tracked over time. So as these things change and evolve, we keep track of that?
Yes, each one of these things is tracked, whether it's flow data, whether it's process data, or context data. They all live in a time series database, and you can go to any point in time and look at this information. If you have an incident that you didn't realize until a month later and you want to say, well, what was the state of my environment last month? You can absolutely do that in Tetration. It will bring up that information in sub-second response times and show you exactly what was happening. Who was speaking to whom, what application was that was involved, and what was the context data associated with those workloads. So it becomes very powerful when you're trying to get visibility and later on use that for dependency mapping and policy enforcement.
Okay, so as well as just having visibility and tracking of these things, I can use these attributes, the context behind the workloads, to actually deliver my policy.
Correct. Each one of these bits of information can be part of a policy entry. I could use the flow information, but more interestingly, I can use process information, or I can use context and metadata about these entities to go and build policies in my environment.
Okay, so that sounds like a much more flexible way to define policy, right?
Yeah.
So it's not just about IP addresses, it's about context.
Exactly. So I could write a policy, for example, that says only users that are part of the engineering group that are using a trusted device, the process must be Chrome, and they are allowed to speak on port 443 to a web server in the data center that must be running Nginx. That Nginx hash must equal this, and they must have the application being web app and the location equaling AWS. Right. I can write that in one policy, which takes account of all of these different data sources, merges them together, and finally comes up with the resulting policy set that will be enforced.
Wow, that is super powerful, Tim.
Yes.
All right.
With that, we are going to wrap up this module on the data sources available to you in Tetration. Thank you for joining us, and if you'd like more information, please visit cisco.com/go/Tetration.